see if I can see them on the class list. It's hard because I know a bunch of students' names here, but I don't know. Oh, okay. All right. It is someone on the list. It really helps if you use your full first and last name when you're signing in, because we got Zoom bombed the other day by someone who was not part of our class. By the way, do you like my backdrop here? I actually, I bought, where do I do this here? I bought like a backdrop that actually is in the background. And so then I can do fun backdrops. Okay, so the plan for today, should stop screen sharing right now. The plan for today is to go over questions from the quiz. You should have your feedback already. Any review, because we have our exam coming up. And then if you do have some questions on 16.1 and 16.2, I have some examples prepared that we could go over as well. Coming up, so tomorrow morning, I have programmed to pop up in D2L the 15.1 through 15.7 exam. And it'll be similar to the quiz, just a PDF document. I'll ask you to do work on your own paper, and then you upload it. It seemed to work pretty well for everybody. I think that worked okay. I'm gonna ask you to watch a lot of videos for next week. So, but you have a week, but you got exam to work on in there too. So watch other videos, and then we'll have a quiz 15.8 through 16.2 next Thursday. My son is jumping. What is he jumping about? Oh, yeah. We got a drop off of some Legos from a friend. Legos are exciting.
Oh boy.
Legos are always exciting. So.
Another Mindstorms.
I know, isn't that nice?
Yeah.
Yeah.
Battle.
Okay, so we gotta go.
That's the only thing it means.
I'm in class.
They shall battle.
Okay,
I will have my 2
so
Mindstorms
let me see here. I should have, where do I do the screen share again? Screen 1. Okay, so it should be sharing, and I do have the quiz 5 here. All right, so first one, everybody did pretty well there. The main challenge there was, I don't know, maybe just a language thing, I couldn't tell. A lot of people knew to use the gradient, but the gradient gives you the steepest like incline, ascent, like the steepest positive direction. And so here you want the opposite of the gradient. You want the negative of that. And so most people, if there was an error, they went in the positive direction. And then number 2, there were a couple of minor errors there. Just maybe you recopied your formula wrong or something like that. I think that was pretty good for that one. And then number 3, let's see here. Yeah, this one was pretty good. You take the 2 partial derivatives and 2 partial derivatives, set them each equal to 0. In this case, you got that x was 0, so that's pretty easy. Then you plug that in and solve for y. And so you know y is 2. So a pretty easy system to solve. And then finding the d there using the formula, you end up with it being a -1, which means it's a saddle point. And I actually took a screenshot of Maple here just to confirm. I don't know if anybody tried that, kind of graph it using some online tools to kind of see. It's not a bad idea to use those. We're at home. We have our computer for exams and quizzes. For the exam instructions, I don't know if I can open those up without giving away the whole exam. Let me see here. Oh, probably not here. Let me see if I can just show you the instructions. Like, you're going to have more than you normally would, actually. So that's kind of cool. Because you're at home. I mean, why not, Might as well use some of the tools that you have available to you. Now I'm going to see if I can just show you those while I'm thinking about it. Everybody enjoying the nice weather?
I wish I was outside.
I got a window open behind me, fan going here. Let's see. I don't want to show more than that. So, yep, same instructions. I don't know if anybody uses Desmos. You're not used to me, but I use that all the time. So that's a good graphing tool. So you could have Desmos open. If you need a calculator, you can download a TI emulator for free if you need that. The Adobe Scan, I think you did a pretty good job with that. And so, you know, more than you might have in class, I'm actually going to give you a Maple Cloud link. That's a link, and you just click on it, and it's going to give you a 3D image that you can manipulate and answer some questions about. That's kind of cool that we couldn't do that if we were in class, but you have your computers or your phone. So that'll be one of the questions. And then the other ones, hey, if you're at home, you had a computer, if you want to check your work and is this really a minimum, go ahead and graph it and see if it backs up. You can't just answer with a graph. You're going to have to show your partial derivatives are both equal to 0 there and do all your work and all that. But, got good tools at your disposal. Might as well make the most of it. So a little bit more than you usually.
Are we supposed to turn in the formula sheets or no?
That's a good question. I thought about it, but I'm okay not seeing that. So yeah, it's all right.
For
Normally,
the Maple,
go ahead.
for the Maple Cloud link, is it dependent on opening that link and actually using it?
Yes.
Okay.
Mm-hmm. Yep. You will not be able to answer the question without clicking on the link because it's asking you about a surface and you kind of need to reorient the surface to really see what's happening. It's really hard to do that. It's actually a problem that I tried to do last year, and I just took like 3 pictures with 3 different orientations, and it did not go well. But I think it's going to go really well here with you being able to rotate the picture yourself.
Okay.
Rotate and zoom. So yes, it does require that access. And if you have any technical issues, shoot me an email. I could record a video of me zooming it and email you the link or whatever. We'll be flexible. Okay, so what else was I going to do here? I think that was it. Oh yeah, quiz 5. So, okay, next, let's talk about the exam. One of the things I always like to do, and this is your first with me, so it's a little bit new for you, but I like to start with just asking, do you have questions about what you need to know for the exam? Not like, hey, can we review 15.5, but like, do you have questions about what will be on the exam or what you should know? Let's start there.
Is there an emphasis on one section over another?
I try to be like evenly distributed. I don't know if it's applicable this section. I'm trying to think. Sometimes if there are sections that have multiple topics in them, that's kind of a nice way to hit, multiple sections with one. So I try to be equally dispersed. There's not a ton of questions on a Calc 3 test, at least mine. Like you can't have, like an algebra test, you can have 20 questions. Can you imagine a Calc 3 test with 20 questions?
Yeah.
Like, no, you have like 8, I mean, that's just what it is. You have 8, maybe an A and B in there, but so some stuff's just going to get left off. And so it's so hard because I would tell my students, like, focus on the things that we talked about in class and the homework questions that we had and the quiz questions that we had. And that's what I'll have on the test. And I don't even know what you did in 15.1 through 15.4. So I'm trying to put like, well, everybody talks about functions, domain, and range, and level curves. And so we should be able to ask about that. And directional derivatives, we could ask about a directional derivative, and partial derivatives and chain rule. So I should be able to ask a standard, find the partial derivative. So I tried to keep questions from those sections just kind of more bland. Nothing super interesting. And then later stuff, I tried to tie it into things that were in the videos in the lectures and try to do similar stuff to that. Yeah. Any other, go ahead, Carmela.
Yeah. So with the review problems, are there other problems like in the homework that we should review, or are the review problems that you gave us kind of like all encompassing everything?
That's a good question. It is, it's close to all encompassing. I would use the review packet as a way, like, by the way, it's really long. There's a lot of problems there, right? This is made to be like, here's a ton of examples for you to work on. If we ask about them today, we might be able to do 4, so we're not gonna have time to go through them all, and I don't have an answer key for you.
Okay.
They're just some examples, but it's a kind of a good way to like, oh boy, yeah, I need to review that section. Maybe go back to the homework and do a couple more of those. You
I
know,
see.
I would say if a student could do that entire, there's like 50 problems.
Mhm.
If you could do all of those 50 on your own and, you know, get those answers, then you're going to be fine. Like,
Okay.
it's pretty exhaustive.
Okay.
You know, there might be a couple of things that are like a little extensions.
Mhm.
One of my philosophies for exams and grading in particular is that I want to know who the A students are. And to me, an A student is not just a student who like can know all the basics or maybe do like a hard problem. An A student is somebody who knows all the identities and meanings and definitions and then can extend it to something just a little different. So there's always going to be one question that's a little bit of an extension from anything you've seen before, and that's intentional. But
Okay.
the bulk of the test should be similar to the homework, should, you know, look just like what you're used to looking at, and you should, a C student should be able to get 75%. So that's the bulk of the test. And so, you know, it should, you should recognize almost all the questions on there, like, oh yeah, we did this and this looks familiar, and yeah,
Okay.
yeah, for sure.
Sounds good. Thank you.
Yeah.
Is there
Any
extra
other?
credit?
No, there is not. The only extra credit that I believe in traditionally, I've done some other things in the past, but typically for a test, I'm not going to do something on the test, because like if it's extra on the test, the only people who are going to get it are the A students. So they're already A students, like it's extra. One thing I do is I have a little buffer. Like, do you ever do those problems? I mean, you've seen me have made these mistakes in the videos if you've been paying attention, where I'll like make a mistake and then I'll catch it and like, oh, that should be a plus. And sometimes you don't catch it. You're like, oh man, you know, technically that's wrong. Or like, there's a classic one in Calc 3 where you find the cross product between two vectors and it happens to be the zero vector, and people just write zero, which is incorrect. Zero is a scalar, it's not a vector, and should be the zero vector. So technically you lose a point, even though you knew what you were doing and you kind of had it right, but technically you were wrong. So I have like usually a 2-point buffer for stuff like that. Like, well, technically you were wrong, but you know, so technically there's 102 points, and it's not extra credit, but there's a little 2-point buffer there. The only extra credit I've done is something that just involves like extra effort. You know, stuff that you just like it's open to everyone. It's not like, I don't like extra credit that's really hard. That doesn't make sense to me, because again, only the A students are going to get it. So there will not be any on the test, and any, if we had it in the future, would be like an extra little project. Like, all right, if you do this extra thing and do this extra thing, maybe it's 5 extra points on the final exam or something like that. And it's just about effort. But I don't have any plans for that. I don't even, I'm struggling just to get like tests written. So. By the way, there are discussions. Was that just a faculty email, or was that all students?
About like the tutoring and everything?
No, there's discussion. I feel like we talked about this last time. There's discussion about some grading options.
They mentioned it, like they're deliberating right now on what to do with that.
Yep. So keep your eye out for that. We haven't been told anything, but they're discussing like no penalty grades, where you know, they're discussing, you know, giving the students the option to pass fail, and you know, so it's still under discussion. That's all I know. All right, any other questions about the exam? Things like, you know, wondering if it's going to be on there or what to expect?
This might be asking a little bit much, but would it be okay to see like an example of that Maple link by any chance, just to get an idea?
Yep. So let me see if I can go Maple Cloud. It's really cool. It's a way, like you work on a Maple file locally, and then I upload it to the cloud. And then I share it, and then it's like this interactive, like it's like a Maple graphic that you can interact with. Okay, so here's one. This was an intersection of two planes, and it's just a link. So it's just a link that I'll give you, and it's linked in the document. So the PDF will literally, you can just click on it or touch it, and it will open up a Maple page like this. And then you can interact with it and spin it around and take a look at it from different directions, and then answer some questions about it. It's not going to be two planes like this, but answer some questions about it then. Does that help give you an idea about what it'll look like?
Yeah, definitely.
Mm-hmm. Yeah. So it'll look just like this on the outside, except it'll be a different example in a different graph. Cool.
I actually have another question. On some of the review questions, it says to graph. Will we have to graph on the exam too?
That's a good question. Let's see. Let me take a look. So level curves, I think, are a very important concept.
Mm-hmm.
And so being able to graph level curves, now that's just 2D graphs, right? Level curves are just an X and Y.
Right.
So do you remember where that was?
With the review problems?
Yeah, I'm in
I
there
just
right
saw
now.
like sketch the domain, but that's just X, Y again.
Yes.
So it'll just be stuff like that.
Yeah, we're not, I did on the, those were chapter 14, right? For that test in my other class, I did ask them to sketch some graphs of surfaces by using traces. And do the XY plane trace and the XZ plane trace and the YZ plane trace, and then draw the traces, and then, this is a paraboloid, and but that's not in this section.
Okay, so it'll mainly
Not
be
in this
like
chapter.
2D, like level curve stuff like that.
Correct.
Okay.
Correct. Yes. Yep.
And it's just everything up to 15.7, right?
15.7. So no Lagrange multipliers, but there may still be optimization problems where you would simply find the critical points. Just using that critical point method where you set the two partial derivatives equal to 0, similar to the quiz, except it's not an optimization problem if it's a saddle point. Like, well, that's not helpful. That's not a minimum or maximum. So, yeah. Yep. So just 15.1 through 15.7. Yeah. So if you look on this packet here is all of chapter 15. So there should be a couple at the end that we can skip. Right, 50, 51, 52, 48. So it looks like 48 on. 48 on, we'll just skip because those are Lagrange multipliers. So.
But we will learn about those.
Yes, so there is a video posted already about those, and then the next quiz will have one of those on it. The quiz, right? You still see that? It's really small, really small.
The quiz for the sections that we've been working on this week is due next week, right? That's the
Yeah,
we're
that
doing
one
next week.
will be at some point. Yeah, I'm trying to figure out, but that one, I want to make sure we have lots of time to ask questions about that. And I know tonight we're worried about the exam. So tonight we'll focus on chapter 15 examples from the review packet. If we have extra time, we can talk about 16.1 and 2. But I want to leave next week for that. At some point, we're going to have to get caught up. And I don't know how that's going to look. We're only in week 2. This is only our second time meeting. So I'm not too stressed yet. But that quiz, 15.8, 16.1, and 16.2 will be posted at some time after next Wednesday's class. Yep.
How far behind are we?
I mean, like a week, a couple of sections. Yeah. So we'll get there. It's all right. We'll get there. We want to make sure that you're still, you got to be able to do double integrals, because then we do triple integrals.
Okay.
and then we do line integrals, which you don't even know what that is. So it's
I'm
okay.
already doing double integrals right now, section
Yep.
62.
Yeah, you should be. Ideally, you should be right now, but it's okay if you haven't. Like, you can focus on the test first, but then you're going to have like lots of videos to watch then, because you want to be through. Because Christian, those were long. Those were some long ones, right?
Yeah,
20
there's
some
like
minutes.
half-hour videos.
There's some couple long ones in there, yeah. And there's like 2 per section for some of those. So So make sure, like, don't say, oh, well, class is on Wednesday, so Tuesday night I'll sit down and watch the videos. That will not go well.
I work, so I try to watch them throughout the week. So,
Yep.
you know,
Yep. Just, you know, I can't imagine taking Calc 2 days a week, Monday, Wednesday. Like, I think that's hard enough. You have that huge 5-day break until you come to class again. So I'm almost suspicious. I almost feel like if you're a good student at organizing your schedule, this almost might be better because you can watch a video, watch another video, try some homework,
Yep.
watch another video, and you can spread that out. But you got to be
that's what I've been
disciplined.
doing.
Yeah, you got to be
Yeah.
disciplined though. Yeah, you have to be disciplined for that.
Because if I used to do it for Calc 2, I did it during the summer, and I would do the homework only on the weekend. And by Tuesday or Wednesday, where I had the class, I'm like, what did I study again?
Yep.
Yeah, so
Yep.
I started to do it. Yeah, exactly what you're saying. Like I'm watching them on Monday. On Monday, I start watch 2 videos. Like today, I watched another video. I think yesterday I watched another 2 videos.
Yeah, I'm trying to be good about posting stuff regularly for you. So there should be like regular news posts.
And before I watched another video, I finished the whole section.
Mm-hmm.
So that's, and right now I'm working on 1612 on the homework problems that I watched yesterday.
Yep. So the videos are posted under the next unit. And so we have some Lagrange multipliers and then 16.1, 16.2, 16.3. And I'm trying to post good, kind of keep you updated here. It's a lot of reading and I apologize for that, but that's just kind of what it is right now. That's what we have to do. Okay, any other course related or exam related questions before we maybe dive in and grab a couple of problems here, tackle a couple of problems to try?
Will 15.8 be part of the 16 chapter?
I'm not
16?
sure about that one. I think that might just be a question where we'll have one on the quiz and we'll call it good. Yeah, I think, yeah, because it's another optimization strategy. And as long as I assess that once, I'm okay with that. So I think we'll probably just have that once on the next quiz and then call it good for 15.8. Yeah. So be sure to try some of those homework problems, definitely. Let's dive into the practice here, or we can do homework questions if you have any. I do have the e-text up, and I can jump to pages there as well. So I'll just open it up. Let me get the chat up. So I've got the chat up too if you want to type anything there. Please feel free to just type a question there, either from the review or if you have you want to unmute yourself. I think we mentioned this last time, but you can, if you have yourself muted, you can just press the space bar and then it automatically unmutes you and you can hold the space bar while you talk. So you can try that too. So who has a request for something to dive in on here? Quiet. No one wants to go first.
Could we do one of the review problems where you sketch the domain? Could we do one of those?
Yeah, let's try. Number 7 looks more. Well, let me just grab them both here. Okay, I'm kind of figuring out some of my technology. I have a lot of windows up though. All right, and let's go to Wednesday. Let me just make sure here. Okay, I am recording, that's good. Oops. And we'll just paste in here. Okay, still I can't figure out how to get it to paste, not as big, but it's okay. Trying to resize it. That's all right. Okay, that's good enough. So we're going to try to describe the graph, state the domain and range, and then wasn't there a graph in there too?
I think those were 2 through 5.
Oh, 2 through 5. Find the domain and then make a sketch.
Yes.
Gotcha. Let's do those. So the key for domains is essentially, it's the same domain issues that you had in, algebra, trig, algebra or trig domains. Is now the problem, the added level here is you have multivariables, but you can't take the square root of a negative number. The domain of the natural log is the argument has to be positive. Inverse trig functions have restricted domains. So essentially what you do, for example, like if we look at number 3 here, it says f of xy equals the square root of x minus y squared. Well, inside the square root, we have x minus y squared. Well, that has to be greater than or equal to 0. And so we just solve that, and that's our domain. I mean, you can state the domain. It's like, well, it's the set of all x and y such that x minus y squared is greater than or equal to 0. Or you could say x greater than or equal to y squared. That's fine. That is the domain. And then sketching that, well, x is greater than or equal to y squared. That's a parabola because of the y squared. It opens to the right. It's not your usual vertical parabola. It's not a function of, y is not a function of x, in fact. And then x is greater than y squared. So the domain would be the region inside the parabola. And so again, the key, it's all really based on the same argument or the same domains that you had in algebra, where you can't have a negative inside a square root. In logarithms, the arguments must be positive. Inverse, like for number 2 here, we have inverse sine of x squared plus y squared over 4. So the inverse sine, there are some restrictions there. Let's do it this way. I'm going to use, say, g of t, maybe theta. We'll use theta. How about, no, it's not theta. That's not good. We'll use g of t equals sine inverse of t. I don't want to use x. I just want to use a different letter here. So what has to be true about t, the inverse for the inverse sine function? Testing your trig here.
It must be between -1 and 1.
Correct.
Much, yeah.
Yeah, you're right. Yeah, I should have held off on my correct and made you second guess yourself. But you're right. You're right. So between -1 and 1. And so for ours, x squared plus y squared over 4 is the t. So x squared plus y squared over 4 has to be between -1 and 1. You can solve that. I mean, it is solved. You can clean that up a little bit, I guess I should say. Multiply both sides by 4, or not really both sides, all 3 parts by 4. X squared plus y squared can't be negative anyway. So the greater than or equal to -4 is kind of redundant. That's always true. It's not wrong what's written, but it's like saying, well, I can only do this if x squared is greater than or equal to 0, but like x squared is always greater than or equal to 0, so then you can always do it. So here, the -4 part doesn't even really need to be there. It's redundant. X squared plus y squared is already greater than or equal to -4. It's always true. So the domain for this one is really just the set of all xy such that x squared plus y squared is less than or equal to 4. And that's just everything inside the circle radius 2. So let me box in those domains. We should write them as sets, and they always look the same. It always looks like, let me do like a different, doing it right here. It always looks like the set of all ordered pairs xy such that, and then you just describe the what's true about the relationship between x and y.
Would we be marked as wrong if we put the -4?
Yeah, it's not incorrect. It's just sloppy and unnecessary, but it's a true statement. Like, it's just, I'm trying to think of, let me think of a different example. So suppose you have a function f of x equals the square root of x squared plus 1. And I ask you what the domain is. And you say, well, x squared plus 1 has to be greater than or equal to 0, which is true. Which is true. And that means x squared has to be greater than or equal to -1, which is also, that's true. X squared does have to be greater than or equal to -1. And so you say the domain is the set of all x such that x squared is greater than or equal to -1. And I say, I mean, that's true, but that's a really complicated way of saying all real numbers. So I'm hesitating because the -4 is really like, it's not an incorrect mathematical statement. See, this mathematical statement is not mathematically incorrect. It's just kind of demonstrates a lack of understanding about what's happening. So you probably would get that 1-point deduction where, like, okay, what you've written is technically incorrect. Or sorry, technically correct. Like, it's technically correct, but it's inefficient, and it kind of shows a little lack of understanding there. So, but it's not a huge issue. All right, does that help, Camilla, on those?
Yes, thank
The
you.
domain? Okay, good request there. Good questions. Any other questions from the review packet?
Could
Or
we
if you
do
have anything else?
a level curves problem?
Yeah. So let me ask this. Whoa, what is that? 9. Did I mean for that 9 to be there? That looks like a typo to me. Doesn't that look like a typo? Why does my snipping not work here? Oh, I'm hitting the wrong buttons. There we go. Okay, we'll do number 8 then, because I think that number 9 is like a typo or something. That looks weird. So I guess before we can do level curves, we have to say, like, well, what is a level curve? Anybody want to type or answer what that is?
It's like the plane at a certain z value, right?
What is the question again?
Just what a level curve was.
Oh, you make C a constant and
Yeah, yep.
Wow.
Yep, exactly. So it's fixed, it's fixing the z value. So if we look at number 8, what we have here is z equals x squared minus y. And so a level curve is, well, what if we fix that z at some c's? Just call it c. And then we say, well, what will those look like? What I like to do here is I try to manipulate it to a form that I'm familiar with. And I notice here, since I have just a y, I should be able to solve for y. So I'm going to add y, x squared equals c plus y, and then subtract c. And so I have y is equal to x squared minus c. I'm going to try to get Maple up here. This is going to be a bad idea because I have like so many windows open right now. I'm testing the ability of my new computer here. And so now we just want to graph those. So I might say, well, what's c equals 0? So that's essentially saying, where does this surface intersect? Well, you tell me, where is z0? What is that really?
Y equals x squared.
That's what it is. Yes, that's what the curve is. But when c is 0, meaning z is 0, what are we really talking about? What's true when z is 0? Where is that?
On the xy plane?
In the xy plane. And so in the xy plane, it's y equal x squared. When c is equal to 1, then y is equal to x squared minus 1. When c is equal to 2, y is equal to x squared minus 2, etc., etc. And it says graph the level curves and label at least 3 of them with their z values. Oh, it got windy, like my door just blew open. Okay, so 1, 1, and then we'll label this one z equals 0. That's going to be in the xy plane, and then minus 1, z equals 1, and minus 2, z equals 2, etc. Okay. Okay. What are the chances that I am able to graph this surface in Maple on the spot? I don't know. Let's see, because I want to show surface contour. Oh, I can't spell. Okay. And here's our surface. And watch this. When we look at it from above, do you see the level curves? It's kind of dark. Color equals, what's a good one? Turquoise? I think a nice light one. Can you see the level curves? So when I look at it directly from above, I see the level curves. Now they look upside down. But that's because the positive y-axis is coming down here. It's kind of the default orientation is x to the left and y to the right. So when I pull it down, it's kind of upside down. We could spin it around. Really make you dizzy here. Whoa. So there, when I look at that from above, I'm trying to, you see the z-axis in the middle here? I'm trying to look directly down the z-axis, and then I get all these level curves. And those are the level curves. When we look at them sideways, they will just be lines. Because they are, I can't get it straight. So when we look at it from the side, they're just lines, because all they are is fixed z values. So from the side, they're just lines. They're fixed z values. And then from above, they are what the curve is intersecting at that z value. I'm telling you, I am not going to go back to regular teaching anymore. Like, like the technology, having it right there, and like, let me switch to this screen. And I did use Maple in my regular class, in the classroom, but then I would be doing handwritten notes on regular paper. And then what would happen is when I wanted to do Maple, I would have to switch the computer off, and then it would take like 30 seconds to get the screen on, and then I'd turn that off and then have to switch. And anyway, I need to pause for a minute. The wind is picking up here and it looks like it's going to rain. So I'll be right back. Hold on.
Is it raining over there?
It's raining pretty hard by me right now.
Oh.
Yeah, I have to check to make sure I close the window.
Yeah.
It was actually hailing by my area like about an hour ago.
All right.
Really?
Yeah, I
Yeah.
think it was just hailing right now. I don't know
Oh,
what's
geez.
happening out there.
Can you send some hail here? We need new siding. We really do. We moved into this house, a beautiful house, just moved in like a year and a half ago, but it's oh, I need to like turn off, like I broke the the virtual background. I need to like reset it.
My
Oh,
car better not get ruined.
Look at that, it doesn't work. It doesn't work anymore. It's like too dark in here now. That's funny. I got it then. I got it.
You green screened yourself?
I did. I'm like green screened out. Maybe this is too bright now. No, look at that. It's all just doesn't work anymore. No, no cool backgrounds anymore. All right, I get to sit in front of my white sheet now. That was interesting that like the change in lighting kind of messed with it. All right. Oh, zoos, no, not the car. Yeah, so we bought this house, but it's nice. It's pretty new. It's 25 years old, but like some of the stuff is all original. So like the roof's all original, the siding's all original. So yeah. All right. Anyway, back to more important things. Level curves. Does that help with the level curves? We wanted to do some of those. So does that help with those?
Yes, thank you.
Yeah, good. That was a good one to ask about. I can jump back over here to this one. Okay. Any other requests? Yeah, limits.
We look at something like 43.
Mm-hmm.
I feel like I didn't spend enough time going through these type of problems.
Yeah, those are. Yeah, those are a little. I don't know. There's a lot of Calc 1 in here, and it's all about understanding how does this relate. Like you remember doing tangent lines in Calc 1, and the tangent line is a really good approximation for the curve when you're close to the point.
Right.
So if you think in Calc 1, you have your function. Here's your point A, B. You draw the tangent line, and you say, well, as long as I'm close to A, my tangent line will be pretty good. When I get further away, it's not as good. It's pretty far off. And so we're just doing the 3D version of that. And we're saying, well, as long as we're close to our initial point, in this case, the initial point will be pi over 4, pi over 4. As long as I'm close to that, the plane, the tangent plane, will be close to the original function. So let's consider the function f of x, y. Oh, I went to like too light here. Equals 4 cosine of 2x minus y. And it says, find the linear approximation at that point. What it's really asking is, find the equation for the tangent plane. That's all it's saying. The linear approximation is just a tangent plane. Now what's confusing to a student is, like when you said line, linear approximation. It's not a plane. A line is not a plane, right?
Right.
So if you think of the equation for the plane, I'm going to write this out here. By the way, if you have a hard time memorizing these, all you need to do, this is what worked for me, is teach Calc 3 once. And then after you teach it once, then you can remember them. Because before I had taught it, I didn't have these memorized either. So it's okay. And then, shoot. That was a bad idea going that far over. But I can cheat and just move it.
Notes is great.
And then plus the z value. So you might say, like, how is this going to be a linear approximation? Well, it's the meaning of the word linear. We assume, like, well, that means it's a line, but the linear actually has a specific definition. And what it means is all the variables are only raised to the first power. That's linear, linear approximation. So, like, you can have z equals 2x plus 3y minus 4w minus 6q. That's a linear equation.
Right.
Because the variables are all raised to the first. So linear approximation is just the tangent plane. That's all it means. Just find the equation for the tangent plane. So let's find some partial derivatives. Partial derivative with respect to x would be negative 4 sine of 2x minus y, and then chain rule times 2. That's negative 8 sine of 2x minus y. And then partial derivative with respect to y. negative 4 sine of 2x minus y times negative 1, again, a chain rule, 4 times sine of 2x minus y. And then we need to find those slopes, those directional slopes at the point pi over 4, f partial derivative with respect to x at pi over 4. That's negative 8 sine of, should be pi over 4, because it's 2 pi over 4 minus pi over 4. And we all know that one, square root of 2 over 2. And so we get negative 4 square root of 2 for the partial derivative with respect to x. And then with respect to y, should be 4 sine of pi over 4. So 4 times square root of 2 over 2, and you get 2 square root of 2. One of the things that happens sometimes is I have to force myself to pause. I remember you will see that, you know, I'm making all these videos, and I'll do one for your exam too. And I'm actually going to give you an assignment after your exam to watch the video for any problems that you didn't get correct. And it'll always be a little astounding to you. Maybe not, but you'll watch the video and you'll see the time, and it'll be like a 20-minute video, which is pretty long. But I did the whole exam in 20 minutes. And you're like, wait a minute, how is that possible? And I'm writing really fast, like I am right now. So just pause me if I'm going too fast. You know, pop up in the chat or just say something if I'm going too fast. So those are our partial derivatives, and now our tangent plane. Question?
No, sorry, I was just like looking out my window. The hail is like really bad right now.
Are you in Elgin?
No, I'm in Bartlett.
Oh man, I need like 20 miles south.
Like it's coming down fast, and it's coming down pretty hard too.
Oh, sure. Be safe. Hopefully Zubair's car is not getting pelted. Oh.
Yeah, so if I lose power, just
Yeah.
that might be the reason.
I was
Not
out.
bad.
It's pretty bad.
It's not good. Not good. That's what we need right now. That's what we need right now, right in the middle of a global pandemic. We need hail so bad that power goes out. And could we make it like 98 degrees too? That would
of
be
course.
even better,
Yeah,
right?
Just give it a couple months.
Okay, so let's see here. With respect to x, so negative 4 square root of 2 times x minus pi over 4, and 2 square root of 2 times y minus pi over 4. Oh, I need the z value there also. So I need to find the original f at pi over 4. Pi over 4. So that's 4 cosine of pi over 4. That's going to be the same as 4 sine of pi over 4. So that'll be also 2 square root of 2. I am not interested in simplifying that, if that's okay.
No, that's fine. Just for completion's sake, is that it?
That's A.
That's it. Okay, and then part B is plugging in those two values.
Exactly.
Okay.
Yep. I wonder.
Okay, that makes sense though.
Yeah, so I was going to try to see like how it would be cool to graph the function, graph the plane, plot the point on the surface, and plot the point on the plane all together. Well, it's almost break time. Maybe I'll do that while we're on break. Maybe I'll try to do that. It doesn't seem a good use of our time together though. But that'll be a fun break for me. Yeah, so yeah, that's all the linear approximation is. It is just the tangent plane, just a fancy word for the tangent plane. Okay, any additional requests? Pop back over here to the review. Any additional requests?
Maybe question, let me find it again. I think it was 31. Yeah.
Mm-hmm. Okay. I vaguely remember doing this one. We'll see if I can remember how to do it on the spot, or maybe some of you will have an idea. Okay, shrink that down a little bit. So we are on a surface, z equals 4x squared plus y squared minus 2. And then c is a path where c is x is cosine t, y is sine of t. And so we're traveling on that surface along that path. Okay, so, well, kind of. So what it is you have the xy plane, and there's this curve C in the xy plane. You know that curve, right? The unit circle. X is cosine t, y is sine t, from 0 to 2 pi. So it starts over here at t equals 0, and then you move around. And then it ends over here at t equal 2 pi. And so what happens is there's a z, 4x squared plus y squared minus 2, that is above that surface. All I want to do is just graph these. So there's a surface that's above that path. And so the question is, as you move along that path in the xy plane, the z is also changing, because the z depends on where you are underneath it. And so letter A is, okay, how fast is z changing with respect to t? So z prime of t is the derivative of z with respect to t. Now the problem is, z is a function of x and y. So which derivative rule are we using here?
Chain rule?
Chain rule. So this is an application of chain rule. We need to find the derivative, the partial derivative of z with respect to x, and multiply that by the derivative of x with respect to t. And then add to that the partial derivative of z with respect to y, and then multiply that by the derivative of y with respect to t. Alternatively, we could substitute in what x and y are and get z as a function of t. I'm a little behind on chat. Zubair, yes. Maddie, thanks for the heads up. Okay, so partial z with respect to x would just be 8x. Dx dt, negative sine t. Partial derivative of z with respect to y, 2y. And the partial derivative of y with respect to t, cosine t. There's a little problem with that. It's subtle, maybe not, I don't know. Does anyone know what the problem is with what I have written there?
You have to plug in cosine t for x and then sine t for y.
Yeah, because it said find z prime as a function of t. It said find z prime of t. So you need to have this be a function of t. Oh, that's fun. So they simplify together and we get 6 cosine t sine t. Nice. Okay, that's z prime. Oh, what's
Sorry.
that?
Is it -6 cosine t sine t?
-6. Thank you. Yep. It's funny that I did the 6, like I knew one was negative and one was positive, so I knew it was 6, and I just didn't keep the negative with it. Okay, and now the question is, this is, I think, the harder question. This is a little more advanced. Imagine that you're walking on the surface directly above C, consistent with the positive orientation of C. Find the values of t for which you are walking uphill. So this is A. There's your answer. So for B, uphill. Well, if we're uphill, what's true? What's true about Z if we're walking uphill?
Tangent will be positive.
Tangent will be positive. Zubair said positive as well. I think you answered correctly a different
increasing?
question. Yeah, yes. So my question was about Z, and Z is increasing. And I think what Carmela and Zubair were asking is, what's true about Z prime? And Z prime, the rate of change of Z will be positive. Yes. So we're going uphill, Z is increasing. So Z prime of t will be greater than 0. So we need -6 cosine of t sine of t to be greater than 0. Okay, all right. I'm not going to be able to do this question without graphing it when we're done, because I really want to draw the connection for you so you can see. Plus, I'm kind of nervous. I hope we did it right, because our graph should confirm what we think. Okay, I'm going to divide by -6, so we all remember from algebra that changes the direction of the inequality. So I need cosine t times sine of t to be negative, which means I need them to be opposite signs. So we need cosine of t and sine of t to have opposite signs. Let's just draw the graph of them. That seems easiest to me. So t, and then we'll just go from 0 to 2 pi. Sine, and then cosine. Okay, and I need them to have opposite signs. So I need one to be positive, one to be negative. So when does that happen?
From pi over 2 to pi, and then from 3 pi over 2 to 2 pi.
That looks right to me. Everybody see that? Those kind of red banded regions there. That's where the first one, sine is positive, cosine is negative. You could do this on the unit circle as well, when the x and y coordinates are opposite signs. That'd be a good way to do it too. All right, so this is true from, we said pi over 2 to pi, and not at the endpoints. They're not opposite signs at the endpoints. We have to leave them out. And I guess we could do union, if we wanted to be fancy, 3 pi over 2 to 2 pi.
And that's our answer.
That's it. Those are the t intervals where you'll be walking uphill. Cool. All right, let's take a 5-minute break and get up, walk around, and get a drink of water, and then we will come back and do some additional examples. All right, stop and mute. See you in a bit.
Anybody else getting hit by the weather? Like, it just went from hailing super hardcore to sunny now out of nowhere.
Yeah, it was raining for me too, and then it just got sunny again.
It's apparently supposed to be happening like all evening, so that's gonna be fun.
Yeah.
Okay, I think it is time for us to get back to work here. A little bit longer than 5 minutes. So I tried to do some maple, but then like, you know what, this is gonna take too long, and had to chat with my wife about the plan for the rest of the night. No hail, she was disappointed. All right, so we were looking at some review questions. We could do more of those if you like. What was our scheduled time here? I'm trying to remember. How long did we say we were gonna go till?
I think you said till 5:30.
Yeah, usually around 5:30. Okay, that sounds good. So we'll see how many questions there are. We could talk a little bit about the new stuff too, but let's focus on, yeah, Maddie's asking about the sessions, and it is, where is my Zoom menu here? Where did it go? Yeah, it is recording. Yep, there, and it'll be uploaded. So if you have to take off, you can just skip to the part at the end. Has anyone tried watching recordings like on, because in Google or YouTube, I know you can do like 1.5 or 2 times. Like I would try that, see if it works. You know, if it's like too fast, then that's no good. But I bet you could go faster than 1-time playback and still be readable. So yeah, feel free to just watch the end of it, Maddie, if you have to take off and head home. All right, let's see if we can get a few more examples done today then before we head out for the night. Does anyone have any additional requests from the review? Thanks, Maddie.
I just have a quick question about 16 and 17. Would you just find the domains to answer that question? Is that basically?
Essentially, yeah. For a lot of those, like, where is this function continuous?
Mm-hmm.
Yeah, so, yep. So if you're looking for where they're continuous, all polynomial functions, rational functions, trig functions, logarithmic functions, exponential functions, they're all continuous on their domains.
Okay.
So finding where they're continuous is the same as finding their domains. That's correct.
Okay.
Mm-hmm. Yeah, right. Any other requests?
Take a look at number 46.
Oh boy, that's near the end. Whoa, I tried to zoom and that did not work. Okay, let's grab that one and take a stab at this one. So this is from 15.7. This is a minimization question, or optimization, I should say. Is it minimum or maximum? Minimum, yep. So we're trying to find the point on the plane that is closest to the origin. So when you're looking at these minimization problems where you're trying to find the absolute minimum, there are 2 things you need to find, and hopefully they will be provided to you. One is you need the objective function. That's the thing to minimize or maximize. And then second is you need some kind of constraints, like, okay, I want to find the point that's closest to the origin. Well, I'm just going to choose the origin. It's distance of 0. Like there has to be some constraint. And so our constraint is that our point has to be on the plane. So for us, our constraint is that whatever point we pick, it has to satisfy that plane equation. All right, so the question now is, we're trying to find the point on the plane that is closest to the origin. So what is it that we are trying to optimize?
Not exactly sure how to answer that.
Yeah, so you have to think about what you're trying to find when something is minimum or maximum, right? And so the question here is, what is it that I'm trying to find where it's at the minimum or it's at the maximum?
Oh, the absolute minimum.
It is the minimum, but the minimum of what? And it does tell you on this one. It doesn't always make it
Oh,
quite
the
so
distance.
obvious. It's the distance. So we're trying to minimize distance. And let's be clear here, minimize distance. And what distance? Distance is between two things. So distance between what? Does anyone have any ideas about that?
The origin and the plane.
Yes and no. So I think I want to rephrase it a little bit. Distance between the origin and a point on the plane. So it's not that we're kind of saying the same thing, but I like to think of distance between 2 points because I know that distance formula. You can use the distance formula if you like. It's the difference in the x's squared, the difference in the y's squared, and then we have 3 dimensions here, difference in the z's squared, and the square root of all that. So it's a 3-dimensional version of the Pythagorean theorem, essentially. But the nice thing for us is that the second point, or one of the points, is the origin. So all we're really going to have for our distance is that we're minimizing x squared plus y squared plus z squared and the square root of that. And I would actually do one better than that. Because minimizing the distance, boy, I'm gonna be taking derivatives here. I gotta do like square roots and oh, yuck. But why don't I just minimize the distance squared? If I find the minimum distance squared, that's gonna be at the same spot where the minimum distance would be. So, and that's a much simpler function. So our objective function, it's a little bit of a problem with it, but our objective function is x squared plus y squared plus z squared. That's the thing we're going to try to minimize.
Okay.
Now I asked this earlier. This happens sometimes. Like there's a problem with this one. As written, it currently constructed, we can't do this. We can't minimize that right now. So does anyone have any thoughts about what's wrong with it, what we need to do? Any ideas? Well, I'll give you a hint. This is a function of 3 variables.
Aren't you supposed to leave it make it into 2?
Yeah, we need a function of 2 variables, right? We have to think of a surface. Yep, Zubair's right. We have to think of a surface. Remember my football, right? With the little thing at the top. We need to have a surface where we can find out, well, actually it's going to be a minimum. So we need it to be a function of just 2 variables. So somehow we need to get rid of x or y or z. Any of them is fine. You just pick one. So you only have 2 variables. That's all. Whatever's easiest. So what are we going to use to get it to be a function of 2 variables? Zubair, you said you could, oh, sorry, I'm going to cut you off, Christian. I saw Zubair chat about we could solve for x. You need a little more detail there. I think you're right. But where would you solve for x, Zubair?
Get rid of z.
I'm asking Zubair, Christian. Hold on.
Sorry.
It's all good. It's all good. Zubair's typing in the chat. Maybe typing in the chat. I don't know. We can't tell if he's typing. So you said you could solve for x, and I agree. We could solve for x. Where would you solve for x? That's the question. Do you know? Or you could unmute yourself and just talk to us. Not sure. Not sure. All right, Christian, did you have an idea?
Well, you have to get rid of is that Z equal to x plus y squared? Oh no.
No, nope, nope. We're not going to be able to just manipulate that function. We're going to need some additional extra information.
Could we set one of them equal to 0?
Nope, we can't assume that one of them is 0.
Could you
There-
solve for x in the constraint and then
Yes.
plug in that?
Correct. This is where the constraint helps. The constraint helps you solve for x. So Zubair's idea was good. You can solve for y or z, whatever you prefer. If we solve for z, most people like, and even my mind does, I like to get a function of x and y. But the problem is if we solve for z, we're going to have this 1/4. Whereas if we solve for x, we just get 8 minus y minus 4z, no fractions. So I would probably do that. But the constraint is going to be the key. That's how you're going to just get a single variable. So now I have f of just, let's see, it's just y and z now. And it is 8 minus y minus 4z squared plus y squared plus z squared. So now I have a function. It is a function of 2 variables. And I want to find when this is at a minimum. So we want the minimum of this function f. So let's pause and kind of go back here. Refresh our just kind of big picture here of what we did. So we want to find the minimum distance. And so what we did is we used the distance formula. And the nice thing is that we're finding the distance from a point to the origin. So the x1, y1, z1, those could all be 0. And so we just get x squared plus y squared plus z squared. We said, why minimize the distance? Why not minimize the distance squared so we don't have all the square roots? Okay, that's great. But now we have a function of 3 variables. We need to be just a function of 2 variables. And so we use the constraint to get it to be just a function of 2 variables. And that's where we are right now. Any questions getting to where we are right now?
Nope.
Okay. Yes. So Zubair is right. Now we take partials. We want to take partials. We're going to find critical points. Now find critical points. I don't know. Is that worth our time? We only have about 10 minutes left. We could do it if you want. The key is to take the partial derivative with respect to y and set that equal to 0. And then the partial derivative with respect to z and set that equal to 0. And what you will get is a system of equations in terms of y and z. You have a couple of options. You can take the derivative as written. You have to do the chain rule on the 8 minus y minus 4z squared. Or you could square it all out and just get this big, long, messy polynomial. I don't know which one is better. Maybe let's just let's just leave it the way it is. So 2 times 8 minus y minus 4z to the first, but then I have to multiply by -1 because of the chain rule, plus 2y, and that's all equal to 0. And then same thing for z. 2 times 8 minus y minus 4z to the first, but then I have to multiply by -4 plus 2z equals 0. And that looks gross, but those are actually both linear. So from now, it's actually, boy, we do that in like basic algebra now. It's just y's and z's. There's no squareds. You just simplify, and you can use substitution method or the addition method, and it's just an algebra problem now. So I don't know what the answer is, but I know you all can do it. Here's a question for you. When we're done, we will have some y and z. But that is not the answer to the question. This is not the answer to the question.
We have to solve for x.
Correct. we also need what point on the plane is closest to the origin. And so we need to find an x, and that's where we can use our x
Go back to the
equals-
constraint.
Yeah, exactly. Go back to the constraint, exactly, to get the point. And so when you're done, you'll bring those together and you'll have an x, y, and z. One thing I always tell students on a test, you're not going to run out of time, hopefully, tomorrow, because you have all day. And if you manage your time well, like don't wait until 11 o'clock to start it just because it's due at 11:59 p.m. That is not a good idea. So, open it up in the morning, take a look at it, kind of plan your day. But if you're still working and you're like, man, I've done as much as I can, I just don't know what else to do here. If you know the process, write your process, write what you would do. Because then you can at least tell me, listen, I know I'm supposed to set the partial derivatives equal to 0, but I just can't get my equation, or whatever it is. Like write your thought process so I can see. Tests are not just a way for us to be like give anxiety, right? Tests are a way for us to assess what you know. And you can demonstrate what you know by doing complete problems, but you can also demonstrate processes by writing down that you know the process. Hold on a moment. I have an 8-year-old at my door. All right. We had a lost Chromebook. You want to say hi to everybody?
Hi.
Hi.
That's Ray. All right. I think you've met Ray before. Okay. Yeah, I think I'd like to do one more problem instead of doing all that algebra there. I think I'd rather do an additional problem. Any additional questions on this one though about the idea, the optimization process?
No.
Okay.
All
right.
Thank you.
Okay. Yeah, good. That was a good one to ask. So let's see here. Let's take a look. I think we have time for one more. What have we done? We did a little optimization. We talked about critical points a little bit. We didn't determine whether they were extremes or saddle points. Tangent plane. We haven't really talked about gradients and stuff today. Steepest ascent and descent gradients. I don't know, any additional questions that you wanted to ask about?
I'm fine.
Okay.
Yeah, I'm okay.
Okay. I know a couple people, I think they might have been, there was a couple people in this class and then a couple people in my other section did discover the Discord app. So, if you have questions tonight, feel free to comment there. And I don't know that I'll be able to pop on later. I will say that so let me open up the exam again. Remember we had talked about some of where did it go? Oh, I think I closed it.
Oh, could I ask a quick question just about the test?
Yep.
So for the sheet that you allow us to have, is it like one side of the sheet or both sides?
I think one side should be plenty.
Okay.
Yep. So one side of a regular 8.5 by 11 sheet.
Okay.
So let me open up these directions again. So one of the concerns that the college still has is, it's such a crazy time and we don't want to add additional stresses to students and say like you have to record yourself or we have to be in a Zoom so I can see you all and you have your camera on and people's work schedules changed and all that. But yet on the other hand, we still want to make sure that it's your work, right? And you're doing it all. And so what I'm going to ask is, I think I'm still sharing, right? So we got the instructions for it. And so the academic honesty here, I just want to allude to this and just say, when you turn it in, you're saying that all the work is your own. Unfortunately, in my other class, I already had an incident where 2 students reached out to a friend. They got stressed and just didn't know how to do that problem and reached out to a friend for help. And unfortunately for their friend thought that they knew how to do it and gave them some bad advice, and they all 3 had the same stupid answer, and that's how I knew that they were working together.
Right.
So, I was really disappointed in that. I'm like, I got enough anxiety right now. I don't want to be dealing with this. They felt super bad about it, and now they have to work back to earn my trust. And so I'm just assuming that once the exam is released, you can't ask me for help on can you do one of the domain questions like number 17, because that could be similar to so once the exam is released, you are working on your own. You can have your formula sheet. You can have the calculator open. You can have a 3D graphing tool. And I'm assuming that I just have to trust you. I'm assuming that you're doing the test under those conditions. If you need to take a break, take a break. That's fine. You need to have lunch or whatever. And, I had one student email me I took an hour and 20 minutes, but I had, my daughter interrupted me and I had to help her with her schoolwork. I was like, that's fine. I don't care about that at all. But I need to make sure you understand that when you're doing this, it's your own work. You can't do any posts and ask questions. You can't email me specific questions tomorrow. Once we're on a test day, you can't ask any questions. You can't look on discussion boards. You can't look for other tools. You can't open up your homework. I just wanted to do that for this exam.
Right.
Maybe in future exams, I'll have an open book one, but trust me, you don't really want an open book test.
No.
Yeah, you don't want that.
I had
don't want
one. I'm taking an advanced mathematics class right now, and we had a midterm for that where he gave us 2 full days to work on it.
Yeah.
And in the beginning, it sounded like a great idea until we actually got the exam.
Yeah.
So
Yeah.
give me an idea of how hard that became.
Yeah. So this one, I'm kind of writing it as you can do the exam in an hour 15. Some students might get done faster. Some might take longer. If you take 2 hours, I don't care. I'm not assessing the time that it took you. So I'm not worried about that. That's it for now. Zubair is asking about chapter 16 questions. Let's hold off on those. And you could, tomorrow. So if you're done with the exam, so I have the Discord chat up right now. And so you could comment in here. You could do a screenshot, if you have your textbook open. Where did my textbook go? You could, I have to sign back in. That's annoying. Anyway, you could take a screenshot and post it, or you could ask about number 617 or whatever on a particular section. You can post it there. And so certainly anything, just not 15.1 through 15.7, that's all. Yeah.
Are you guys covering 16.2 tomorrow?
Yeah, so in class tomorrow, in my 2 p.m. class, we're going to meet. You are all welcome. We're going to be going over questions from 16.1 and 16.2 and 16.3 for them. So
Okay.
that's what I mean. They're a little ahead of you. We did a bunch of double integrals over rectangles and other regions. That's 16.1 and 2. We did those yesterday. And so tomorrow we're going to do some more polar coordinates, some double integrals with polar coordinates. So, but you're welcome to come. And I have not been posting those links for you because I didn't want to overwhelm you. They are public on my YouTube channel. So you're welcome to dig around there and just search for Mth230 and you'll see Monday, Tuesday, Thursday links also. I don't know. I know you have a lot of stuff to do. So your time is limited and I respect that. So.
Are the answers for the review problems that we went over today, they're not, no?
There are no answers.
Oh, that's awkward.
There are no answers. I don't have time. I didn't have time to do that. I just thought, it's kind of, it's tough because the way that I designed it originally was I would give it to students and then we would spend all day in class students would just work and then I would just walk between answering questions. That doesn't work anymore.
Yeah.
So I don't know. I mean, and my time is limited. You've seen, like I'm recording videos after the kids go to bed at like 9 o'clock at night because it's quiet, but then I'm like super tired. And so it's not ideal. So I just don't have time to do all that. So it's kind of an exposure for you to see the types of things I expect you to do. And at this point, I'm kind of hoping you have ways to check your answers. Partial derivatives, you can check some of that in. Does everybody know Wolfram Alpha?
Yes.
That's a great tool. That's a free kind of mini maple. And it's not as picky about syntax. So that's kind of nice. We have the graphing tools. You can use those graphing tools to kind of check if you're on the right track. And so, yeah, that's the best tool I can offer for that, unfortunately. I do not have an answer key for that one.
Thank you. Oh, and
Yeah.
then, so the Discord chat, how do we join that? Because I tried clicking it in the,
Doesn't work?
no.
Okay.
Yeah, it
So,
gives you an error message. I tried the same thing.
did that link expire? Gosh. Okay. All right. So let me do this right now, because I should be able to just give a new live, because there's a way to have create invite and then set this link to never expire. I swear I fixed that, but obviously I did not. Edit this navigation bar. Discord chat. Ah, it is the old one. God. Okay. Save and close, and then now it should work. Let's see.
Yep, it's working now.
Cool. Oh, why is it? Still doesn't like mine. It's mine still, even though I updated it, it doesn't like it. It's not refreshing to the new one for me for some reason, but oh, now it finally saved it. Oh, there was like a delay. That's interesting. What? I don't know. Email me. Email me. I can post the updated one. So I'm going to make a news post. Let's see, update from tonight. And I'll eventually post the link to the recording as well. So in case Discord link is not updating, here's the correct link. Thank you for letting me know about that. Any additional requests or questions?
Yeah, I would prefer
good.
to ask this probably after the exam or like sometime next week. With that, I mean, that's the whole problem. Like, we don't meet up till next week. Realistically speaking, we have like about 4 weeks left
Right.
before the final. So what do you see in terms of like logistics with that?
Man, I'm like living day to day.
Yeah, I know it's really rough. It's just I have like 3 other classes like I've had to
Right?
schedule like so much around with too. So I'm just trying to get an idea of how to plan things.
So is your question about like, because I
Like,
want to get in this regular rhythm where we'll go over now I want you to get in the habit of watching throughout the course of a week about 2 hours worth of videos.
you're right.
Right? That's my goal, is that you're going to have about 2 hours worth of videos to watch. And then we'll meet once a week. You can come to the other meetings as well, but my goal is that like we'll meet and we'll go over examples from those videos. And then we'll have either a quiz or exam every Thursday.
Mm-hmm.
And there's going to be some stuff that I have. The problem is I can't ask other people who are teaching this class this semester about what they're doing, because I would just be emailing myself.
Yeah.
So, so I ask some colleagues about, hey, here's where I am, here's what we have left. What would you leave out? And so there might be some stuff at the end where I might record videos and just say, listen, Stokes' theorem, these theorems at the end, they're like super cool. That's like the whole point of calculus leads up to them. That's why I'm like, that's like the best part.
Right.
So I don't know what to leave out.
Circumstances.
Yep. I don't know what to leave out. I don't know. I don't have an answer to your question.
Sure.
Sorry.
No, that's fine.
I am thinking about it. But
Do you know how Mr. T is doing?
Yeah, he's at home. He was. Did he? We did an update. It was a while ago though, right? So
Yeah.
let me.
Yeah. Last time
And I don't know if I shared that with everyone. Some of you might not have been here.
I don't think I'll see
Yeah,
her.
the letter to everyone, right?
Yeah, let me pull it up here. And I don't know why he didn't just email everyone. He may not even know how to find his class list. I don't know. I don't know. Because I know he emailed me. Okay, here it is.
You guys already got the storm, and I'm barely getting it right now. Where are you? It looks bad.
Okay, it is really dark out right now.
Yeah, you'll get like in a short burst and then it'll go away quickly.
Okay. All right, we're
I'm
going to
sorry,
share. So for those who haven't seen, this is Professor Teichert's letter. I think you can see all that, right?
Yeah.
Yeah. Yeah, so he had a minor heart attack earlier in the semester. Everything was fine. After that, it didn't require surgery. He was able to bounce back. But since then, he had a severe infection. It was in his aorta, actually, was his infection. And that they were able to calm it down with some medication and some treatments, and it was stable and everything's fine, and he's at home. It might require some surgery. They're still monitoring it. But the doctor said, you need to get out of the hospital and just go home for now, because they didn't want him in that condition, being in the hospital with all these coronavirus cases in the hospital. So he was stable, emailing in good cheer. His wife said he was feeling a lot better. So, I haven't talked to him in a couple of weeks. I haven't touched base with him. So yeah, it seemed to be, it seemed to have stabilized a lot, and he didn't seem too concerned, but it was a little scary there for a while to have an infection in your aorta when you've already had some health issues there. So it was pretty scary. Yeah. Mm-hmm.
Glad he's doing better.
Yep. Yeah, for sure. All right, everybody, enjoy the rest of your evening. I know you have other work to do. I have a news post program to pop up at 8 a.m. tomorrow with your test, and it'll be a PDF. And the only thing you can email me about is if you have questions about logistics, but you can't ask me about specific questions, but feel free, if you're having trouble with scanning, or if you want to even clarify what the question is asking, you can do that. That would be best in a public forum though. So if you do get on the Discord, that would be good. What did you
So other
need?
people could see it too.
Correct.
The submission is still the same too, right, on Dropbox?
Yep. Mm-hmm.
Okay.
Yep. There's a Dropbox in D2L waiting for you. I think that was on my list of things to do.
Yeah, I saw it on there.
Yeah, it's crossed off. All right, everybody. It's nice chatting with you. Stay safe.
Thank you.
Thank you.
Bye, everybody.
Thank